Hello everyone and welcome to the channel. Today we are going to build this animation using Euclidean Distance and Python with Pygame. This animation consists in a network of dots connecting to each other with lines and also connecting to the mouse position. Without further ado, let's get started with this animation. First, let's grasp the math behind Euclidean Distance. Imagine having a 2D platform with x and y axes and 2 points, point A with coordinates 1 and 1 and point B with coordinates 3 and 2. And we want to find the distance between A and B. What would be the value for this distance and how do we obtain it? There are numerous ways to obtain this distance, but we will use the Euclidean distance because it measures the straight line distance between 2 points in the Euclidean space. The distance is obtained by the following formula: the square root of the sum of the squares of the difference of all the dimensions. In our examples, with only 2 dimensions, the Euclidean distance can be determined like this. Replacing the values into the formula, the result will be 3. So for this point A and B with coordinates 1 and 1 and 3 and 2, the Euclidean distance would be 3. So now let's start building this small project. We have to import Pygame. We have to define the screen size or the window size. We have to define a background. These are global variables. I'm defining them up here because we are going to use them throughout the code. And then also colors and primary colors, secondary colors, and then the background. Both these two colors and then these two colors. These I have two because between connections between the mouse and the dots, it will be one color as shown in the example in the beginning. If we have a smaller distance, it will be a brighter color. If we have a long distance, it will be a more darker color. Same goes for here. So first of all, let's initialize pygame dot init. Let's add a header to it. Pygame dot display dot set caption. Let's say Euclidean dots, for example. And then Pygame, let's build the screen first. Actually, x equal to pygame dot play dot set mode. We need to pass the height and then the width, and then we need to build the application loop. In order to build that, I'm going to build a function so we can call it in a function. Def main. Let's build the a while loop. Now, in this loop, we need to handle the breaking conditions. We are going to do this by checking the Pygame events, the close windows event on the close icon, and then also we can choose like a key, for example, the escape key. So if the user press the escape key, it will close the windows for us. Let me just write the code for that. So now we finished. We handled the closing condition both in the close icon and then if the user press the escape key over here. We need to add the background color to the windows and then also call the update function. Then we did that. We need now just to call our function. Can run this. It will show just an empty string, empty windows because we didn't anything else there, but we will now structure the animation. Let me close this. To do the animation, we need two things. We need the dots and then also we need the animation itself. Right. First of all, let's start doing the dots. I will create both classes for both of them and then I will add the attributes both for the dots and then for the animation. Class dot. I will add the attributes. One of them will be the dot radian. Let's import radian. And then we need to add speeds. I will be the list of speeds, so we can choose from them randomly. I'm doing it this way, but you guys can generate them with the rand function, but I want to build them this way because I can control them. And the speed, we'll have to, let me just import this. This is the X speed, and then we need the same thing for the Y speed. We need to add a color for the dot. We can call in use, and then we need to add an initial, and then we need to add an initial position to the dot. We can take it as an argument when we are creating an object for this class. So I'm going to, this will be a list. Okay, and then we need to determine we need to define the distance that we want to draw the lines between dots. We could set a fixed value, but for me I will give a random value, so each dot has its own distance to check, and then the mouse position I'll put it to be a fixed value. And also we need the mouse position. Okay, that's it. Now we need to build our functions that we'll need to use in this class. First of all, we need to get the position. Need to get the position. This will be a list, and then it will return. We could do that in just accessing the attribute throughout an object of this class, but I prefer to get it through a function. And then the mouse, let's build a function to check the mouse connection. In here we will just check if the Euclidean distance between the mouse and a dot, it's hitting the values that we defined for the mouse distance up there, and then if it's hitting that value, we will draw the line between the mouse position to the dot position. So first we need to get the distance. This will be the Euclidean distance, but let's implement the Euclidean distance first. We are going point 1, which will be a tuple, and point 2, which would be a tuple, and then this will return an integer for us. To calculate the distance, we already know the formula. What I'm going to do is build the formula here, and then I will explain it to you guys. I have it, and then I should elevate it to the power of 0.5. Why I'm elevating it? Because this is equivalent of the square root of this value. I don't need to import the functions from math. I the math over here. The x values, the x from p1 minus the x from p2 elevated by the power of 2 plus the y value for p1 and for the minus the y value of p2 elevated for the power of 2. All of these the square of all of these will be our Euclidean distance. So here say self-dot Euclidean distance, and then we need to get, you can do this tuple self-dot mouse position. We need to press tuple dot self-dot position. Okay, now we have the distance. Just need to check if the distance is on the connection, the distance between the mouse and the dot, it's less than the mouse connection distance up there. And if it is, we will draw the line. Let me implement it, and then I will explain it. What I'm doing now, I'm just adding the darker color and then the brighter color. I will say that till 150 it will be the brighter color, and from 150 to 200 it will be the brighter color. Get the secondary color, and then we should pass the position. And let's add it to be 3. And one thing, we don't want it to draw lines that are out, at least for a margin outside of a bit close to the end of the screen. What we can do, we can create a condition here. Let me just paste this. Okay, let me create I'll create another condition here, which will that. Okay, if we were just checking if it's in between that range and self dot. So let me just show you what I meant. What we want to do with that is we don't want dots that are close to the borders. We want at least to have 10 pixels, so the maximum connection will get through from here to anywhere inside one imaginary box that we are putting there. So we have that connection. We need to handle connection between dots. How are we going to do that? Just create another function to handle that situation. That will be def, let's call it order dot connections, self dot def and order dot position. And this will be a list because we need to pass a list of all the other dots in order to check that if there is any connection between those dots. Let's build it. First of all, we need to check the Euclidean distance. Let's run over these dots for pause. For position in order dots position, let's calculate the Euclidean distance. Let's say distance will be self dot Euclidean distance. Let's set between the position. This should be, and then now we have the distance. We need to check if the dot respects the point distance that we just declared over here. If it respects it, we will draw the line. If not, we won't draw any connection between two dots. So let's, in order to do this, we need to check if that's the distance. How do we do that? It's just a condition. Let me build it. We have two colors, this color and then the con color one. We need to make if it's a close distance, we will add a brighter color. If it's a long distance, we will add a more darker color. So let me implement that. Just like that, we already have the connections between dots and then the line. But we need to do something else with the dots because we need them moving. We will just create functions to change the dot direction. So let me create it. What I'm doing that is if the dot is moving on an x-axis, if it passes the screen width, it will reverse the speed. So if it's going on that direction, it passes the screen's wide, it will invert the direction. So now it will run in this direction. This is what I'm basically doing there. And then we can also change the radian. Now we need to handle the same situation on the y values. So if okay, that is a condition handled. So now we have all the dots functions. We have the get position. We are getting the we calculating the Euclidean distance between dots, and also we are checking mouse connections. We are checking other dot connections. We are changing the direction, and for now what we need to do is to draw the dot, of course. Let's do a draw function over here. In order to draw it, we just need to say again dot draw dot circle and pass the screen and self dot the color in use color the position and also the radius. Okay, but we need to do some stuff here. We need to get the update the mouse position. We need to update the mouse position. We need to check for connections through other dots. Other dot pause, yes, it could be like that. And we need to press it here. It will be list. Okay, then also we need to update the position, because if we don't update the position, the dot won't move on the screen. Then other thing, we need to check if the dot is going out of the screen. So self dot check change direction. Okay, so the dot is done. We already implemented the dot. We need to build our animation by now. Class animation. What we need to do is generate a number of dots and draw them in the screen and check their connection. It's just that what we need to do. So that we will, let's number, we can start it at 200 for example, and then we can generate the dots. Dots list, just dots, we can say dot, and then here we'll have to pass position. Let's just say 4 dots number, and then here we can generate a position regarding the screen right. So pending we need to pass a tuple here, because as we remember it receives, let's go back, this should be a tuple. I have a list there, but it should be a tuple. Pending between, let's say, from position from the pixel 20 on the X for the position on there, we will do the same thing to the height. Then we already have our dots. We need to draw all the dots on the screen. Def draw all dots, let's call it like that, and we need to draw, and then we need to check for mouse connections, and then probably we can improve this a bit more. So let's say we have a list of dots. We can basically just for dot in self dot dots, for dot in self dot dots, it could be dot dot draw. That will do the work for us without anything to add there, but we will need to get the other dot positions. So one way to do that, so we need to pass all the other dot positions there. We could do another comprehensive for there. So for example, dot get position, and for dot in self dot. Okay, but we can improve this a bit more. Instead of doing it here, we can take that and put it there, and then do this here. Okay, so that will do the work for us. We can check the mouse connection, and it should probably work as it is now for us. Let's just come here for animation, will be equal to animation, and over here we can just animation dot draw dots. Let's check if this works. Oh, we have an error here. So we have an error here. Let me just solve it really quick, which is that it must be a list, and then this must be a list, and where I have tuples, it should be a list. Okay, now it should work. Let's see. List out of range. Okay, let me just solve some quick problems here. Okay, with saying that, okay, I got it. Just see what is wrong there. Let me just check what is wrong there. It is saying that you might have a problem there. Let me just check real quick. So by now I know what the error is. Basically I did something wrong here. It should be 1 there, and if we run it, we will have this crazy thing over here. But this is because here it shouldn't be like that. It should be these, and then here it should be like this, and then we will have the animation here. So let's make some improvements here. We already have the animation, but one thing we could do is to generate new dots while when the users click. We can create that function. This won't return anything. So self dot point or point, calling them points, but they're not points. Def generate new dots. This function generate new dots will have self dot dots dot append dot pygame dot mouse pygame. It will be pygame dot mouse dot get pause. Okay, now I have a function to generate new points. What we can do, it's here we can check for if the users click the left mouse button, and then we can generate new dots. For example, if pygame dot mouse dot get press, what can we do is check 3, and then we are checking the position 0, self dot generate new dots. So if we run it now, if we click here, it will generate new dots for us. You can see we have new dots there. It is generating new dots for us. Okay,